All right, folks, a very warm welcome. Great attendance on a Saturday morning. I think it's very hard to expect you are in the States and you'll have people turn up for a community event on a Saturday morning. But happy to have you folks. I think a couple of you were in attendance for yesterday's talk as well. And I think it's an extension to our talk that we did yesterday. We'll try to cover some more aspects and some more about content and platform engineering. I believe folks who are attending my talk for the first time, have you heard of Cordant by any chance? Did you hear about Cordant? So that's the tool we are going to talk about. Primarily, it's an open source tool, and we will obviously be covering an aspect. Justin will be talking about an aspect of how AI is driving platform engineering. That's the goal of this talk. But before I even introduce myself, I would like to introduce how we believe we have orchestrated all of this. The idea is empowering your platform or your infrastructure with Kubernetes as the single source of truth. And Kubernetes is not just good for AI; it's the ideal solution. That's the thought process today. I mean, we are experiencing the amount of GPUs that are running today. They are using Kubernetes under the hood. They Kubernetes are running on GPUs, and it gives you the right building block to create your infrastructure. But AI ML on Kubernetes is still painful. We have not we are There are so many projects that have come out. K Agent is has become so popular. Kubeflow is growing, another project by Red Hat. There are so many projects. K8s GPT found its way, but is still, I think, there are parts where the community has created a lot of issues. So I mean, NYAMLs, yeah, right up there. You have to manually set up a lot of these tools. There isn't any process, and that is where I would like to set up this talk where we have tried to standardize this approach, create a process around it, and this is how we envision the future of intelligent operations. I'll share my slide deck from yesterday, that how there is a tooling sprawl, there is a Kubernetes sprawl. People are on multi-cluster, multi-cloud environments, but there are immense number of APIs under the hood which are helping you manage your infrastructure. But this is how we envision the infrastructure of tomorrow. Kubernetes as the orchestrator, as the scheduler for connecting all these multi-cloud, multi-cluster environments, and then you are having AI driving your environments to help you envision it better, manage your resources in a better way, manage the state of your environment, different services, your Calico, your Cilium, identify, and it has to be role based in air gapped environments. So this is how we envision platforms of tomorrow. With this, I would like to introduce myself. My name is Prithvi. I'm a CNCF ambassador and a senior community manager at Mirantis. This is my journey. I started off with chaos engineering 5.5 years ago, and now it's a lot of platforms, Easy Kubernetes, K0s. And Justin, would you quickly introduce yourself?
Yeah, I'm Justin. I'm the director of AI projects at Mirantis.
Thank you so much, Justin. So, what's on the agenda? This is an unfinished cake that we have, and we hope that we can serve some cream with the agenda that we have. We can share some insights with you that helps you finish this cream. Imagine this as your platform, as your developer portal, and this is what we are going to complete or try to complete post this talk, or hopefully help you add some cream to it. So there are three critical infrastructure challenges in terms of what people are building with AI. There is a tech stack complexity. Ecosystems aren't matured, but we are served with a lot of AI in the last 2-3 years. People have not been able to reach a solution where they are able to build their interfaces or their tech stack right. The standardized approach is not there. People are, of course, they are adopting, say, if you have to talk about platform as a service, I mean, people have adopted Heroku, a lot of folks have adopted, or there is an adoption of OpenTofu because Terraform changed its licensing. But I still believe people have not approached the right tools. If I have to talk about multiple teams, a couple of teams I'm aware of who are trying to adopt CI/CD. There's one team which is implementing Argo, but the other team is implementing Flux, and I'm surprised why there is a missing standard in a company in itself where two teams are adopting different solutions. And that is where tech stacks have become complex. Customers, where I mean, eventually a business is driven by how your customer approaches you, right? And customer wants a complete ecosystem that just works, even without caring how the company is trying to build it. And that has, I mean, that has created an operational inefficiency where you're thinking about innovation, but vendor dependencies are not really helping you. And that's the, I mean, there are a lot of folks where tenant isolation, skill gap, innovation, all of this has created a mismatch between infrastructures and how to create the best infrastructure as a service or the best infrastructure for your customers. And I mean, this is the new approach that I was talking about yesterday. People have moved to the microservices architecture, but there is still a legacy approach towards creating these distributed systems. You need to ensure your systems are composable, you are using the right tools, and even if your clusters are dynamic in nature, you are bringing the right changes. You need to leverage what you have decided or the thought process behind it. You need to have the option to tweak your clusters or to tweak your infrastructure. And of course, they have to be flexible in nature so that even if you are adding or subtracting something, there are no outages or resiliency issues that perhaps make it difficult for you. So this is the real platform of today. I have created a few aspects that are basically helping you create a composable or a complete platform. I believe if you have to deliver or ship your software faster, you need to ensure that a complete software solution for the interface, you are having an internal developer platform portal or an IDE in place, which can be Lens or Visual Studio, whatever you're using. You need to have your security testing orchestration, your software supply chain assurance in place. I've taken an example of Falco. A lot of folks in the CNCF ecosystem are adopting Falco. Your CI/CD has to be in place. Feature flagging, another important aspect. I believe you need to ensure that you're using your features in the right way. You flag it when it's not essential, and then you utilize it when you need them. That is my main platform foundation, which helps your pipelines, your getting your GitOps in place. Your resilience engineering, again, I spoke about it yesterday, I'll talk about it now as well, that you need to have your integration tests, your performance testing, your incident management, your service reliability in place, and then obviously resource optimization, your engineering insights, and cloud cost management. This is my idea of a true platform today. And then you use your observability, your FinOps, your AI over this. And let's talk a little bit about the dark side of the platform realm. What today's platforms look like. Even if platform engineering, it's focusing on standardizing the approach, creating a better developer experience. There is a dark side to it. I mean, I took a Star Wars theme to it. I am not a huge Star Wars fan, but I took a Star Wars theme to it to one at one of the talks that I did at not DevCon, CloudCon Sydney. And the current state of platforms is the platforms are overly complex. You are not focusing on your core needs. You need to begin by addressing the right challenges, how what your developers are facing today, why they are forced to do a lot of ops and learn a lot of new tooling. You need to adopt the minimal viable product mentality, because it's real world requirements, right? You cannot just think that, oh, I need a lot of AI, I need a lot of easy tech, cloud native tech, new tools, K agent, LLMD, VLLMs. That's not how the approach has to be. You need to start small and then grow, and then regular reviews. Of course, you need to periodically assess what's going wrong, and that's why there are overly complex platforms that has kind of affected this motion of moving towards platforms. Even the most built platforms are not something that developers are able to understand, because they don't have a user centric design. There's no continuous support. You need to offer robust documentation, but documentation and training has been missing for accessible support. You're not able to demonstrate the right values which show developers that you can work on it or enhance what you're using. And as I spoke about Heroku, OpenShift, there are so many platforms. Nothing against OpenShift. Again, I know it's a Red Hat conference, but I mean the rollouts have to be incremental. You cannot just you cannot introduce practices that need learning. You have to start small, create a project in place, and a feedback loop as well, because you need to get feedback from your users. And that is why I'm a huge supporter of open source technology and not just buying licenses and just keeping them unused. So the evil, of course, trying to integrate it to legacy architecture. I feel that a lot of organizations have not moved towards distributed systems and are still using legacy architecture. Maybe there's a lot which has moved towards VMs and bare metal, but a lot has not moved towards, say, microservices or Kubernetes. I know a lot of organizations, especially banks, that are still moving towards Kubernetes. Leave aside, moving towards the new tech. So people need to gradually modernize, have a modular design and middleware solutions, of course, in place to bridge this gap. And Kubernetes sprawl. I think before I talk about security, there was a slide where I talked about how big the CNCF landscape is. You need a microscope to check out the tools that are available at your disposal in the landscape. So before you move towards using the right tools for your cloud native solutions, you have to have the standardized tooling. You need to assess the ROI and then grow towards it, even if you're doing a POC or moving it to, say, a CI/CD or staging environments. How many of you here are aware of OpenSSF? Just a show of hands. Okay, there's OpenSSF. So OpenSSF, again, it's a platform, it's a foundation which has created or focused a lot on security. Today, if you are creating an open source tool, or if you are moving it towards, say, CNCF incubation, graduation, you need to have a security OpenSSF badging in place. And tools have to be secure by design. You need to integrate the right practices, have RBAC controls, encryption in place, regularly audit, train, educate your teams to practice more and minimize the human error. So this is what a lot of platforms are missing, and there's a security sprawl in its place. And then, of course, scalability and performance bottlenecks. You need to be able to scale. You need to have your autoscalers, your HPA in place, which a lot of organizations again are missing. Because there's a lot of text, I'm trying to move faster through these slides. So before I move to the last slide on the dark realm of platforms, cost optimization is missing. Folks have not really adopted a cloud cost optimization model. I think I organized a meetup in Bangalore a year ago on cloud cost management, and 100 people signed up showing interest for that. And eventually 10 people turned up to that meetup, which spoke volumes of how cloud cost optimization is seen. I know a lot of cloud providers provide a resource optimization solution, but that's not all. I believe you need to reduce your infrastructure spends in the right way, use the right tools, start small, maybe with an open cost, which is an open source solution to your cost managements, and ensure that your operational overheads, the overall resource utilization is again becoming efficient, so that you can pour in more to build platforms rather than just managing your cloud infrastructure. And of course, you need your monitoring, logging, traces in place. Open telemetry, it's a very popular tool. Metrics need to be defined. You need to have alerting, and that's why I believe platform engineering and your observability run hand in hand. So platform engineering has evolved through multiple stages, from being separated as developers, ops, then DevOps emerging, centralized platform teams. I wrote this in a blog, a CNCF blog. Perhaps you can check it out after this talk, or I can share it with you. But the concept of a platform group has not emerged yet. I mean, there are companies who have hired a lot of platform engineers, but a platform group has not emerged where you can redefine your roles, because your producers are just, I mean, not the platform teams, it's your consumers as well. Your platforms have to be fast, efficient, and you need to involve your developers, your SREs, your overall teams, your operation teams, and your decision makers alongside your customers to make your platforms democratic and help develop them better, standardized with the right approach. And one more thing I believe drives platform engineering is infrastructure as code. I mean, I don't need to define what infrastructure as code is, but the idea is to create the right IDPs and abstract the complexity, right? And that is where infrastructure as code helps you standardize that approach, reuse the code in place, drive automation and consistency, so that you are able to effortlessly manage your platforms, your environments, even if they are on dev staging or production environments. Your disaster recovery and rollbacks become predictable. You have to ensure that there is a foundation for your self-service developer portals, and that's where I like the fact that Crossplane and OpenTofu become an open source solution for it. And then you have to ensure that it's supporting GitOps. Security and compliance are pretty important. The people are enforcing open policy or Kyverno for their policies. There are service catalogs that have to be discoverable, your vault, your SOPs. So you need to ensure that infrastructure as code becomes a backbone to your platform engineering practices, and you are able to repeatedly automate or abstract your internal platform operations. With this, we'll talk about what we started with, the Kubernetes native approach, the idea behind it. I mean, Kubernetes is a powerful scheduler, but we are not able to implement it in the best form, and that is what we tried to do. The goal was to create use case specific IDPs, use the right tools in a templated way, ensure that your platform engineers are not facing a lot of complexities. Developers find it easier because of the Kubernetes shift that has been going since the last 10 years. A lot of developers have been, I think, well versed with Kubernetes. And as I spoke about today, there are multi-cluster, multi-cloud deployments, and while creating your IDPs, you need to ensure that platform engineers are able to manage them well. So these are the kind of deployments we see today: your AI/ML configurations, your hybrid multi-cloud environments. I don't think anyone is using a single cloud or a single environment. They have to be multi-tenant in nature. You need to maintain isolation between your teams. And then data sovereignty has been pretty important. DORA matrices have been so popular in Europe. So you need to ensure that there are country specific and regional specific rules that are being followed. In the interest of time, I won't talk a lot about this slide. The focus is more on infrastructures, and that is where a full stack AI solution from metal to model that we are talking about is key in terms of capabilities. We start small. You are able to provision your bare metals, your metal 3 redfish, configuring them in the right way, and that is where the concept of infrastructure as a software came in or was brought up. So the idea is now to build infrastructures and ship them. So when you're able to drop an operating system onto, say, a resulting instance, you're able to work with whatever your customer requires, say Linux or any other operating system that is being provisioned. You provision your GPUs, onboard them, because there's a partition needed between your operating systems and your overhead GPUs. And then your Kubernetes comes as the main layer of abstraction, which is basically helping you orchestrate your multi-cluster, multi-cloud environments. And then above the infrastructure as a stack, which includes your bare metal operating system, GPU, and multi-cluster environments, you provision your different dependencies. It can be your GPU operators, it can be your Kubernetes dependencies, which can be any of the services, states, Ingress, MongoDB, and then eventually you provision your NVIDIA NIMs. And that is how the layer looks like. So this is what a readily manageable Kubernetes cluster will look like eventually. You have your cluster template in place, which we'll talk about how the templating looks like. and then you have your service mesh, your K-serve, your GPU operators, your cert manager to manage your certifications. Multi-tenancy, again, I spoke a lot about multi-tenancy, but this is how multi-tenancy becomes complex. Your tenants are not just interacting with one sort of environment, but say this is one kind of environment where they are interacting with your VMs, then your hypervisor, then your overall developer portal, your stack. Then your tenants might interact with a hypervisor, and then they interact with the operating system, or a tenant might directly interact with an operating system, which makes multi-tenancy complex, and there are no options which help you manage your multi-cluster, multi-cloud environments. And that is where I thought that there can be a solution to distributed management, distributed container management. And I think this is a slide from yesterday where we introduced Cordant as an open source solution that helps you manage your multi-cluster, multi-cloud environments. It has a cluster manager, a state manager, FinOps, and your monitoring, logging matrices, everything together, so that it helps you manage your distributed infra. This came as a community request as well, that we are having separate solutions for each dependency, but why not deploy a super control plane to manage all of it together. So this is what Cordant, I mean, this is your infrastructure, different infrastructures. The idea of Cordant is to manage, your full stack from metal to model, truly multi-tenant, and then of course your platform as a service being managed by Cordant as the mothership or the main cluster. So this is what we have created in terms of infrastructure as service. What is the right technology stack? You need to have a centralized control plane, which Cordant does as a mothership. You need to you need to ensure that you are able to manage your bare metal services, the networking in place. They have to have a service lifecycle management, so that even if something goes wrong or when you are trying to provision them, you have the right management in place. Today platforms have become virtualized. There's a lot of talks about virtual Kubernetes, vClusters. So obviously people are moving towards a virtual Kubernetes environment as well. You need to integrate it with your microservices or your Kubernetes workloads. And then Kubernetes is being used as a service here with Cordant as the single source of truth. So you see, once Cordant is deployed, how the stack looks like, how your multi-tenant infrastructures look like. Even if there are different tenants in place, your Cordant is coming in between to basically help you interact with your bare metal hosts and your Kubernetes environments, your virtual Kubernetes and your VMs. So Cordant is using ClusterAPI under the hood, which is again helping you manage your clusters, and it also uses Cosmotron, which is another open source solution for lightweight Kubernetes driven by K0s, and then Cosmotron, which helps you manage a hosted control plane. So it is not just your control plane for your worker nodes, but you have a hosted control plane to ensure that your systems are multi-tenant and deployed in the right way. This is an example of Nebel. They are one of the users of Cordant, and these are the challenges they faced. They had operational complexity, were not able to provision their full stack AI cloud, operational toil with Kubernetes clusters at scale. There were data privacy issues or concerns they had, and the idea was to streamline multi-cluster ops across their diverse infrastructure, support multi-tenant operations, which I believe I have spoken about at large. And this is just an example of one of the users. And these were the results. They were able to create this ideology or thought process of GPU cloud as a service, efficiently not just provision their clusters, but their AI inferences, which I believe Justin will talk about in a minute, how he believes or ideates provisioning AI inferences can not just be done with Cordant, but in an overall way as well. And that is why we followed a templated approach. If you see, instrumenting a cluster API, an instrumented CAPI is pretty complex. People have tried using other solutions, Rancher, D2IQ, they have been pretty complex. And that is why we've tried to follow a templated model where you just have a YAML file that you can tweak according to the service, according to what you require. And that is where it interacts with your container registry. It is stored as cluster templates, service templates, and provider templates. All of them templates where you are defining your kind, your metadata, everything that you require, and then you provision it according to your environments. So I'll take an example of how does a predefined service template look like. These are the service templates that we have. You have your cert management, your disaster recovery, service mesh. For each and every service that you are using, you have a template in place which is using Sveltos under the hood, another popular project to manage your Kubernetes add-on controllers. And this is an example of a cluster management template. So you see, maybe I could zoom it, or I'll just let it be so that we don't have any issues. We'll show it later. A cluster management template has its API version, the kind deployment, which is a cluster template, your metadata, your spec, and then your infrastructure. Which infrastructure you're using? Is it an AWS, Azure, OpenStack, vSphere, and then your cluster config, which is basically your version and what kind of CNI service, the service directory and the pod directory that you use, and it's an immutable version, so you can define it according to your requirements, and it is available on a hub. In the interest of time, I am not covering each service template or each template, which is a service template, template on FinOps, and template on cluster providers. But yeah, this is what the catalog looks like. You have predefined service templates for Calico, Argo CD, Dapper, and many other tools. There are like around 80 or 70 predefined templates that are available on the catalog, and it is an open source solution. So you can, just deploy Cordant and pull in a catalog according to the service or according to the cluster definition that you are trying to manage. With this, I would hand over my mic to Justin, who will talk about, building AI infrastructures and how, agents are driving the infrastructures and platforms of tomorrow.
Yeah, thanks, Prithvi. So, in the because we're running out of time a little bit, I'm going to go off script, but I find myself director of AI projects at Mirantis, which is an infrastructure company, and I end up spending most of my time trying to figure out how to build agentic processes for DevOps and for managing clusters and for making DevOps essentially easier for operators. And so one of the things that I'm seeing more and more these days is trying to build agentic systems to manage clusters, to manage our multi-cluster setups. And so we get into this agentic layer. What does this look like? We've solved cluster provisioning with Cordant, but we're really getting into a place where it's almost more about context engineering. In order for these agentic systems to be able to take action or provide useful information back to us, we need to provide that context to the agent so that it can answer us appropriately. So I've seen many teams struggle on this point, which is that it's never about the models. The models are getting better and better and better, but it's more about how to make them operationally aware of the situation that they're dealing with. So how does your AI know that pod XYZ is actually your payment service? How does it understand that a memory spike at 3 p.m. on Tuesday is normal because that's when your batch jobs run? You have to be able to provide this context to your AI agents in order to do that. And so one of the ways that we can do that is via Model Context Protocol. How many here know about MCPs at this point? Awesome. So MCP it's very new. It was built by Anthropic this year. And security was really kind of an afterthought. It's still an afterthought. We're solving this with OAuth. It's being addressed. But it filled a really important need, which is how do we get these agents to talk to each other? How can we expose our systems that we already have to the agents so that they can give us the information we need? At the end of the day, these LLMs, AI, it's not magic. If you give them the right information, they can provide us answers to problems. And so here's a few of the MCP servers that I think are worth checking out. at least in this domain. They're quite good. And so it's just another integration standard. MCP chain, it's universal, it's an open standard. And so we're moving from this reactive to predictive in this space. So let me show you an example of what context engineering might look like in this domain. We can think about context in 4 levels. Level 1 is static, your cluster configs, resource limits, the stuff that doesn't change often. Level 2 is dynamic, current metrics, active pods, real-time state. Level 3 adds history, so past incidents, patterns, what happened last week. Level 4 is where it gets really interesting, is where you can do predictive context, anomaly detection, trend analysis, forecasting. So here's an example. We could have an AI agent monitoring our cluster. The agent knows memory usage is at 78%. That's level 2, dynamic context. So we can query Prometheus via an MCP and see that the same pattern happened last Tuesday at 3 p.m. That's level 3, historical information. The agent can then query the batch job schedule via another MCP connection, still level 3, but here's level 4. Given that the agent now has the necessary context to draw conclusions, we can ask the agent to look for patterns and see if it can predict if the spike is one-off or if it's likely to happen again. Because the agent has the context necessary, it can then take action, which is quite cool. We can then proactively scale the cluster 30 minutes before the spike. No alerts fired, no pages sent. Platform can self-heal at this point. So it's quite cool. When you start deconstructing these problems down into agentic systems, now you can actually start doing these jobs in a way that's never been able to be done before. So, the first question that always comes up is, great, AI is going to replace all platform engineers, right? Negative. So incident detection, sure. AI never sleeps. It's watching 24/7. But humans understand context that AI might miss. And the best approach is that agent detects, the human validates. It can help us with root cause analysis. It can help us with remediation. We're not replacing platform engineers. We're giving them superpowers. And imagine never having to write another PromQL query or never having to SSH into a production server at 3 a.m., never having to manually correlate logs across 17 different systems. Your platform can then become strategic. And they define the policies, they set the guardrails, they can make architectural decisions. The agent handles the repetitive, mundane stuff that platform engineers don't want to deal with anyways. So this is kind of the future of the agentic platform team. Human creativity and judgment augmented by AI, consistency, and scale. I don't think I'm going to have a chance to run through this. We have a very cool system that we're building called the CSP experience. And this is the core of what I focus on day to day now, which is this idea of bringing the non-deterministic world into the deterministic world. We've created a set of components and building blocks that we can implement in DAG workflows or pipelines, you can think of it as, but it's actually a DAG graph. And then we have a DAG executable, which allows us to use pretty much any CRD as a component in our building blocks. And we have full UI capabilities to do drag drop DAG building as well as execution. It's very cool. Fortunately, I'm not going to have a chance to show you the demo. But yeah, that's our talk. Any questions? Anybody have anything that they want to bring up? Thank you so much.
So it's either you use a Helm chart.
Can you repeat the question?
I think I think the question is, how do you install Cordant? So it's either you pull in a kubeconfig, an image, a kubectl command, or it's a Helm chart. Any other questions?
All right. Thanks so much. Thank you very much.